In this question, we're told that two particles A and B of respective masses 2 kilograms and 5 kilograms are attached to the ends of a light inextensible string which passes over a smooth pulley B. The two particles are held at rest and at the same level above a horizontal floor with the portions of the string not in contact with the pulley vertical. A lot of this we would have assumed from the diagram. We're told that the system is then released from rest. For the period before B reaches the floor, calculate the acceleration of the system and also the tension in the strings. These are the things we would always try to find in a pulley question. Okay, I'm just going to quickly make my own diagram. The strings, the particles, the forces, and here's the ground right here. So we have the two weights and the two tensions. Those are the forces we're interested in. How about the direction of motion? 5G, being the heavier one, is going to move toward the ground, while 2G is moving upwards. Now we have enough to form two equations. And we're going to be using Newton's second law, F equals ma. Let's start with particle A. We can say that T minus 2G equals 2A. For particle B, we can say that 5G minus T equals 5A. From these two equations, in this form, we can easily find the acceleration. We're just going to add the left-hand sides and add the right-hand sides, and we get 3G equals 7A. A equals 3 over 7G. Now let's substitute this into A to find the tension. T equals 2A plus 2G. 2 times 3 over 7G plus 2G simplifies out to 20 over 7G. The acceleration is 3 over 7G. The tension is 20 over 7G. And I will just keep everything in terms of G. I haven't needed a calculator at all so far in this question. Plus, using decimals, we're just going to be losing accuracy every step of the way. So let's stick with fractions and expressions in terms of G. So we found the acceleration and the tension. The question then goes on to say eventually B reaches the floor 0.5 seconds after release and does not rebound. In the ensuing motion, A does not reach P. So the rebounding and A hitting the pulley, these are things that students who are overthinking start to worry about. So the question is trying to alleviate those worries by telling us that. We just need to focus on the 0.5 seconds it takes for B to reach the floor. Determine the greatest height of A above the floor. Okay, before we move on, I actually want to know what is the current height of A above the floor. We know that it takes B 0.5 seconds to get to the ground. So let's use that to find the distance that we are currently from the ground. So, collecting Suvat variables, we know the initial velocity was 0, final velocity we haven't found yet, acceleration 3 over 7g, and it was half a second. All of this goes into our formula, s equals ut plus half at squared, and that's actually a half times 3 over 7g times a half squared. All of this we can do in our heads. 7 times 8, that's 56, 3 over 56g. The displacement is 3 over 56g. So it's initially 3 over 56g from the ground. That's how far B will travel to hit the ground. That's how far A will travel up into the air before the system breaks and it starts to move freely. Let me just produce another diagram here so we can see exactly what's happening. And so there we have it. A is going to start to free fall from 2 times 3 over 56g meters in the air. Let's track what happens to A from here onwards. We do need to know the velocity B hits the ground with, because this will be the initial velocity for A as it moves into free flow. Okay, so using the same variables, using V equals U plus AT, and substituting in what we know. The velocity is going to equal 3 over 7g times a half. No need for a calculator once again. 3 over 14g, that's the velocity B hits the ground with. It's the initial velocity of A as it starts to move freely. Now let's focus on A as it's moving freely. We want to know the greatest height that it might achieve. So, initial velocity, 3 over 14g. We're looking for the displacement. V equals 0, acceleration, trying to make sure we're staying in terms of g, is negative g. The formula to use, v squared equals u squared plus 2as. Substitute in what we know. And once again, I haven't really gone for a calculator at all. Here we're just demonstrating. The examiner would want you to demonstrate your algebraic manipulation skills. We have 3 over 14g squared minus 2as minus 2gs. And rearranging, s is going to be 3 over 14g squared divided by 2g. And here we can now reach for our calculator, 0.225. So the total height above the floor, it's 2 lots of 3 over 56g plus the extra 0.225 we've just found now. Altogether, the greatest height that particle A reaches is 1.275 meters.